Good morning, good afternoon, everyone. We are very pleased to welcome you here for this next generation digital twin session. So we are from Dassault Systèmes, and we would like to present to you what are our solutions for the virtual twin and how we leverage data to improve the MRO operations. All right, let me introduce the speakers and participants for today. So first, James Kornberg. He is an MRO expert who worked for more than 20 years within Air France KLM. He now works at Dassault Systèmes, and he is a business consultant, and he will be pleased to answer your questions. Morgan Zimmerman, a CEO of the NetVibes brand at Dassault Systèmes, he'll explain you how we leverage the data to build the virtual twin of an aircraft. Stefan Erben, also working in the NetVibes brand at Dassault Systèmes, and he is in charge of the definition of the portfolio. And I'm Jérémy Tillier. I'm working within the aerospace and defense team at Dassault Systèmes, and I'm responsible for the maintenance solution portfolio. All right, let's get started with a quick presentation of Dassault Systèmes and the aerospace and defense trends. So if you don't know us, if you don't know Dassault Systèmes, we are a large French company. We gather over 20,000 employees around the world, and we work with more than 12,000 partners. We have almost 300,000 customers who are using our solutions. We have offices all around the world, of course, in more than 130 countries. We have three main headquarters based in Paris, in Boston, and in Shanghai. So, what is our belief? We think that using the virtual world, using simulations, using science and data is really key to better understand, anticipate, and improve the real world. So that's what we believe in, and that's how we design our solutions. A little bit of history of Dassault Systèmes. As you have understood, our legacy is the digitalization of process. When Dassault Systèmes was founded in 1981, we designed parts in 3D. We continued along this path, along the engineering, the design engineering path. And only 8 years later, we supported the full digital mock-up of an aircraft, the 777 of Boeing. Then we went further with the digitalization of the manufacturing processes. In 2012, we released the 3D experience platform that goes far beyond the engineering or the manufacturing domains. It gathers on a single environment all stakeholders and data to collaborate through cross skills and through cross area. For instance, we created the virtual twin of Singapore. And our last major transformation was to reconsider all of these domains, engineering, system, manufacturing, around experiences. So we wanted to ensure that human sciences, nature, industries were able to run through experiences. And for example, we work on the virtual twin of a human to fight COVID during the last month. So, what is the 3D experience? 3D experience is a platform that gathers brands applications for industries. We do not only focus on aerospace and defense, we are working with other industries, and we get knowledge from every industry to transfer and to replicate it then in other industries. In terms of brands and solutions, you probably know CATIA for the design. And if we talk about maintenance, repair, and overhaul, it is mostly used for retrofit, for instance. So here is a quick overview, a sample of some of our customers. Within the aerospace and defense industry, we offer a large portfolio of solutions for our customers, and I will describe that portfolio here. We have Keep Them Operating. Keep Them Operating is part of the overall aerospace and defense industry solutions experience. It covers the entire aircraft life cycle. And as you can see here on this chart, it goes from the idea of an aircraft to the end of its life, going through system architecture, design engineering, and manufacturing engineering. So I was talking about Keep Them Operating. Keep Them Operating is a part of our global portfolio, and it focuses on the main domain of support and service aftermarket, starting from the OEM with the service item, the definition of the spare parts, the definition of the maintenance tasks. Then it goes to the maintenance planning and the maintenance execution with the airlines or with the armies, with MRO operators, to keep the aircraft and its systems operating. So, what are the different challenges? What are the different trends for aerospace and defense industry today? So, among the different challenges for this industry, with Keep Them Operating, we focus on 4 key challenges. First is the spare part market. These drive, for the time being, a lot of cost and inventory, but there is also a lot of opportunities to reduce this and to increase the margin in this domain. Secondly, the amount of maintenance data is really exploding now in both commercial areas and defense area. But however, most of the airlines or defense systems are not equipped at the moment to leverage this huge amount of data and to consolidate them to drive predictive and optimized maintenance on the aircraft. Also, the digital discontinuity due to the number of disconnected and not synchronized, or even sometimes the unwillingness to share data. So most of the actors don't see yet the large value of sharing the data, but we believe that in the future there's a large opportunity to optimize data and to have a win-win for those new innovation technologies. And when you look at the maintenance itself, especially its execution, it's still a lot of paper-based. It's still not completely connected in a digital manner. So that you have the visibility at any point in time, and you can optimize the operations process. So based on these key challenges and to achieve that virtual twin vision we leverage the digital continuity through life cycle, from the ideation of a product to the in-service operations. And with the 3D experience services, we can improve connectivity and collaboration between all domains and all stakeholders, from design to manufacturing, from manufacturing to the first prototype, to its certification, and then from production to maintenance and even to recycling or dismantling operations. So here is what we want to achieve. As you can see, if we talk about the maintenance topics globally, we have different scopes. We have the service engineering, we have the technical data authoring and publication, we have the maintenance planning and scheduling, we have the maintenance execution, and we have the feedback loop, or at first the collect of the data and the feedback loop to the engineering side to run innovation, to improve the product. So that is where we will focus today with you. We want to talk about how we will collect the data, how we collect the data to build the virtual twin of an aircraft, and how we leverage this data, how we give visibility to the users to this data to improve the way you perform your maintenance, repair, and other operations, and how we can innovate from this data. So I will let Morgan now talk to you about the virtual twin and how we consider it.
Hello, my name is Morgan Zimmerman. I am the CEO of NetVibes at Dassault Systèmes. And today I'm going to tell you how virtual twin experience powered by real-world data can help transform the way we maintain and operate complex objects, such as an aircraft. But let's start from the beginning. At Dassault Systèmes, as part of what we call Industry Renaissance, we are helping our customer go from product to experience economy. So I'm not going today to do a complete presentation of what experience economy stands for, but to make a long story short, let's say that everyone in this room that are not anymore selling a physical aircraft or a physical engine, but are selling an hour of fully working engine, is indeed already in the experience economy. What we have seen in the last few years with all of our customers is that to deliver that ability to serve your customers with experiences, it requires to transform the way you work within your own organization, to reconnect silos within your organization that don't typically talk together. Customer support, sales and marketing, engineering, manufacturing. And I'm going to try to illustrate how we actually do that. To do that, we use what we call virtual twin experiences. You will see demos of that later today. But to try to make a long story short, the virtual twin experience, it's all about positioning in one single place the most advanced representation of the product, of the factory, or of the company. In most cases, this is a 3D virtual model of the aircraft, but it can be a system taxonomy. All of the real-world data, field issue, sensor data, as well as all of the people and the collaboration processes that goes along with it. To make a long story short, science and data science together, this is Google Maps. I'm going to give a simple analogy. If you need to find a restaurant nearby a flower shop, and I give you an Excel spreadsheet with the address of the restaurant and another Excel spreadsheet with the address of the flower shop, you have a challenge. But if you go on Google Maps, everything becomes simple. Here it is the same. If you have corrosion data, stress data, requirements data, sensor data in separate files, you're lost. But if everything is projected on the virtual model of the aircraft, it is by construction already contextualized for everyone. Not only that, but the next step is when you find a problem, if what you do next is to send an email, then you're dead because you've lost traceability. You can't learn from the efficiency of the decision you have made. So you need to connect the people and to connect the collaboration processes in one place. So this is what we call virtual twin experience. Science, modeling, simulation, representation of the physical object to be managed, all of the data projected on that object, and all of the people that needs to contribute in its operation, and the whole of that in one place. To deliver that, we have empowered the 3D experience platform with few things. One is a big data infrastructure that allows to support, the ingestions of any scale of data, including, unstructured documents, pilot reports, technician reports, sensor data, scaling to tens of billions of events. We have a semantic model, an ontology model, that actually allows to have the most advanced representation and normalization of all of this data, so that all of the portfolio of collaborative, authoring, simulation applications can interact on this data in a fully transparent manner because they're sharing the same model. You might have seen at Dassault Systèmes we represent everything these days with if we loop. This is very important to us. It means that it's not anymore a sequential process. You design an aircraft and then you sell it, and eventually you will learn later from the problem. But this is a continuous process where everything that's happening in the real world, meaning with your aircraft being operated, is serving what's happening in the virtual world to imagine, improve, enhance, manufacture, new aircraft or maintain the existing aircraft. So it's a continuous process, and it's a multi-scale continuous process. Obviously, you can learn from the previous generation how to better design the next generation, but it's also it can scale down to the daily operation. What can I learn from the way I've supported a specific type of problem yesterday to improve the way I will support it tomorrow? On the data science part, without going into the details, we have the ability to collect any piece of data, structured or unstructured, image or 3D, in any language. We elevate it into ontology and knowledge graph thanks to artificial intelligence. And then we have advanced capabilities to navigate that data and empower the users, the analyst, so that they can drive the investigation in the most effective possible manner. Long story short, we have developed very specific technology here that are capable of managing the complexity of a configuration. You know, an aircraft, it's by itself, it's not a set of transactions, it's a configuration, it's a bill of material. And at the node of this configuration, you do not have numbers like what you have in SAP. You have statuses, requirements, semantic. So we have developed technology with extremely advanced capabilities in terms of managing graph transversal, joint queries, semantic queries at the same time. We believe in the expressiveness. We are the only one that have developed the right piece of technology to support the complexity of product. Not only that, but when it comes to machine learning, as an example, we are relying a lot on data governance method to make sure that any recommendation, predictive models, is always traceable, so you know what was the version of the model at the time you took a decision, that learned on which data, and so on. And finally, it's relying on ontology, as I mentioned earlier, which are well governed and life-cycled. On the collaboration piece, let's make a long story short. We want to eliminate all of the traditional disconnected collaboration methods. So whether this is emails, whether this is spreadsheets, whether this is post-its on whiteboard, whether this is a to-do list, we have implemented into the 3D Experience platform a very large set of collaboration methods to serve various collaboration purposes, from a governed collaboration purpose with milestones and gates because you have certifications, to highly unstructured collaboration methods with digital post-its, to empower the way to connect, as I mentioned earlier, all of the users that you have within your organization or outside of your organization to solve specific problems. If I go back to the core topic of the day, which is how do we maintain aircraft? So obviously, if we want to maintain an aircraft, we need to know how it was designed, how it was manufactured, how it was operated, how it behaved, and eventually, you know, for the purpose of which mission. Obviously, when we mention that this is a challenge, you know, many companies or people, they start to believe that the right thing to do is to do a data lake, because indeed you need data coming from multiple systems, so the data lake looks interesting. But in reality, the data lakes, it's a good first step because it allows to put all of the data in one place. But it doesn't solve the problem because it doesn't give you a projection system. It doesn't give you a taxonomy. It doesn't help you do correlation, segregation, contextualization. So it's not an enabler for solving the complexity of the problem you have to solve to operate a fleet. In our belief, and this is what I said earlier with virtual twin experience, the digital model is by nature the most interesting representation to project and contextualize the data. So it's not about collecting the data and putting it into one single store. It's about projecting that data onto a referential, and the digital model of the aircraft is by far the most relevant referential that will allow contextualization, system-based segregation, security management, and so on. But not only that, but then when you do that, you need to look at the data from different angles. You need to look at it from the angle of the fleet, because you want to optimize the availability of the fleet. You want to look at it from the availability of each individual aircraft, or from the availability of specific equipment. Not only that, but the fact is, to solve challenges and issues, you need to empower, enable collaboration, trigger collaboration between the organizations that may be everywhere, you know, that are doing, you know, the engines, or that are doing the systems or the missiles, and so on. So when I mentioned virtual twin experience is at the core of everything, that's a good potential illustration. Connect the whole of the data into the virtual model of the aircraft around specific data analytics and data investigation application to manage fleets and performance, while triggering the relevant collaboration methods with all of the industrial players that may have a role in this play. I will let the rest of my team get you more details on how this actually works. Thank you.
Thanks, Morgan, for this introduction. Now let's see what are the key challenges for the maintenance of aircrafts in operation. The major goal is to ensure the digital continuity across the extended enterprise. We have on the right-hand side what we call the real data. This data is coming from the plane, from the maintenance teams which are producing reports and during the maintenance and repair activities. And all this real life data has to be mapped on the virtual twin in order to take advantage of all the information coming from the design and the engineering. This product lifecycle management will help the teams to perform better during the maintenance activities. And this will be done thanks to the virtual twin by mapping real life data on the asset definition of the systems. Now, to improve the overall availability of assets in operation, there are different parameters that have to be taken into consideration. The fleet availability can be seen as a breakdown between many parameters. The first one, and an important one, is what we call the long feedback loop. This will consist in analyzing all the defects coming from the different systems and planes and see if we can find any commonalities that might help to say if this problem has been identified to be neutralized using the failure and mode effects analysis, or if it's a new problem that might need to be solved for the future generation of assets thanks to a design and engineering change. On the other hand, for the existing asset fleet of assets in operation, the major goal is to anticipate a future failure and globally the availability. Now we have also what we call the short feedback loop. Once you have anticipated a failure, you still need to plan a maintenance date for the inspection or for the repair. And during this repair and maintenance activity, the challenge is to be able to reduce the time it will take to investigate and to repair. This is what we call reducing the mean time to recovery, meaning that you can release the equipment sooner to be send it back for the production or for the operation. And for that, you can take advantage by leveraging the knowledge that you have captured from past situations, where it can help the teams to get quicker to the root cause. And the second is also to leverage all the resolutions reports and services built in that has been produced by the engineering and the design team. But even if you have considered these two parts, it's also important to make sure that you have a good overview about the supply chain ability for the spare part management, because some of the parts might be very long to procure or long to produce and might have quite a long lead time. And on the other hand, you also must make sure that you will have the optimized resources and the right skill to do the repair and replacement activities when it is required. So we see here that there are many facets that have to be considered during the maintenance activity. Now what we produce in the 3D experience platform is what we call 360 views. These 360 views are done on different facets. We have the fleet level, the aircraft level, the operational level, the supply chain, and many other views that we can produce. The 360 view on the fleet and the aircraft will help to improve the mean time between failure, because you will start to do what we call the evidence-based investigation. It produces mainly the key metrics analysis which are required to do the overall view from a top management. And it will also help to analyze the issues and compare it with the FMEA studies to see, as I said before, if these issues are new or they are just have to be considered to be corrected for the future. Now, if you want to anticipate future failures, you need to implement what we call predictive analytics. Here we produce a 360 view on the equipment and the system, and this consists mainly in calculating what we call the remaining useful lifetime and or the system health statuses on the major equipment, so that we can know and understand when failure might happen. This is done thanks to feature engineering, which will consist of enriching the context of the data-driven approach with other insights that will help to better train the models that then will be able to detect the weak signals in the data. The 360 views on the supply chain will help also to see if the spare parts are available, if we have the right safety stocks, and make sure that we have also the correct genealogy to track all the serialized items that have been installed, replaced, which are in stock, and so that we can also manage the supplier risk to know if some supplier might have produced, let's say, derogation on any parts. This is also important for the analysis. And then also, to do the inspection and the repair activities, you must ensure that you have the right people for the right operation with the right skill. And this will mainly require internal and external collaboration, because you will have to synchronize with a lot of subcontractors, suppliers, and partners to ensure that all these activities will happen in the right way. And then you need to also track the progress to make sure that it has been done on time. And then also for the inspection and the repair activities, we produce what we call 360 view on the issue investigation, on which we will help the people to get knowledge extraction from similar cases that happened in the past, on which you can find the resolution reports. This will help to speed up the investigation and reduce the time to repair. Last but not least, we have also the 360 view on what we call the corrective actions, so that we can provide or produce recommendation for the team. And this is mainly done thanks to the semantic classification that we can do on this, what we call unstructured data, which are mainly the report and the fact sheet that we can analyze, in which we can find import and relevant information for the teams. This will also help to capitalize knowledge by connecting the different reports together with the facts. Now, looking at that, you will have to analyze the fleet level activity, the aircraft level activity, and the system level activity. Depending on who you are, maintenance manager, contract manager, technician, you will have to have access on the different level of system, and this will be done by many people. So we will see that many people will be involved. They will need to have access to different level of nature of data in order to know exactly what they are going to do. So here we see that in this ecosystem, we have many stakeholders that will be involved: OEM, certification bodies, partners, suppliers, subcontractors, or an extended enterprise view. And all these different stakeholders, they will have to have access, especially on some parts, but not obligatory on everything, but they need to have access to the requirement, the specification, be able to consult data in different formats, leverage data coming from IoT, and all this has different views on the system or on the equipment or on the aircraft. And at any time, what you need is to be able to see the data from the operation, data from the maintenance, or from the design together. And when you look at this globally, it means that you have more than 100 stakeholders that are involved in this type of activities, which are, most of them are using their own data sources or their own system to record and report what they are doing. And in many cases, these are representing a quite important number of different systems. Most of the time, we have more than 50 different types of data sources, which all these partners and users and subcontractors are using, and which will not be replaced. So the challenge is to be able to connect all these different siloed information together in order to find the commonality that will help to bring to the maintenance users all the relevant information at one place. And this, of course, when you look at the amount of data that it's representing, including the IoT, of course, you have to crawl across more than 50 or more than 1 billion of records. So that's really the challenge. So how are we doing that? Finally, as I said, you will have multiple type of data sources, structured, unstructured, that you will have to connect together. And this will be done thanks to what we call a knowledge graph, in which you will have the ability to define links between the system in which you will capture the event that is coming from the field, and then to build relationship that will help you to understand how to get to the root cause. And this will be done because you will stepwise have to analyze different data in different systems, giving you information for different disciplines at different moments. And thanks to these different links that you can build and bridge together, it will help you to drive your investigation better and faster. So this information, now that we have captured it and made it available in one, let's say, unified model, what we call the knowledge graph, and which is abstracting the complexity of the different IT system, what we will do, we will build on top of that what we call an ontology layer. It means that in different moments and in different disciplines and different people might talk about the same thing but with a different wording. And at the end, if you want to be able to apply rules and do investigation, it is important to have a common understanding of the different meanings that you have. This ontology layer will help to build this foundation, on top of which then you can implement what we call the data sciences, which are the models that are going to be performed to train and to detect weaknesses or in the signals or find commonalities between problems. And so with this system, we will be able to abstract the complexity from the field, to make the information available in a unified way, to do what-if analysis and analyze the data coming from reality with a failure and a mode effect analysis and see what might be wrong. And then, in addition to that, we provide also the capability to take advantage from the real-life data and for the important or the critical system to map them into the simulations application that we have on the virtual part of our digital twin, which will help to see if what happened in reality was expected thanks to the simulation, or if we can use the simulation to explain why we had a difference in reality. And this is really something that will bring a lot of more insights to the users. For the simulation, we have a subset of different technology that help to make simulation at different levels. That can be at the micro level, like molecules or nano. And we have also other types of simulation capability that can all be connected together in order to make a system which can be an equipment with mechatronics capabilities. And if you go further, you can really build a system of a system that can help really to understand in virtual what is happening. And this capability will really help the team to represent on the virtual model complex things that you cannot understand if you don't see them, or you can also use the model to reproduce and make visible phenomena that are hidden just because of the structure of the plane or the system, or just because of the nature of the signals. And having this ability to bring all this in the 3D experience available in one single place, having the ability to collect the data, to reveal it, and then also to collaborate between the different stakeholders, which are all in different disciplines, gives you the ability really to improve the maintenance and to be better in the way that you repair and reshape, let's say, the activities. Now, let's see in reality how this is happening and how that is implemented. And I turn now to Jeremy, who will make you the presentation of a real-life case. Thanks.
Thank you very much, Stefan. So let's take a few minutes to go into the 3D Experience platform and run a quick demonstration of our solution for maintenance optimization. So what you can see here is NetVibes application that is used within the 3D Experience platform to collect data and to manage our maintenance KPIs. We have an overview here of different KPIs on the aircraft equipment or aircraft structure. As usual, we manage the use of the 3D to reveal the criticality of some issues or some defects that have been detected on the aircraft, and we can filter these issues by criticality to harness and to investigate through some specific issues. As a collaborative platform, we really want to show you here how we manage the program management through project planning. So we will assign some tasks to investigate the issues that have been detected on given aircraft. And to do that, we create some tasks that are now in progress. So this task has been taken over by the technical specialist, and he will now be able to run some investigation over the different issues that have been reported. Here you have an overview of data collected. You can locate through the 3D where are the issues detected. So in that specific case, we will focus on the brake temperature sensor, and we will run some investigation on the brake temperature sensor data. As we have all the data available in one database, we really get a 360 degrees view of an aircraft and its flight in order to compare equipment problems between each other and get the root cause analysis. We can always navigate and use that cross-domain platform to ensure that we have the full visibility of the systems. For example, here we are navigating within the architecture systems of the landing gear and the aircraft. So we can use that to better understand what is the snowball effect, for example, of one specific issue, how it could impact, in our case, the temperature sensor, and that will help us to investigate through the different data that we have available here. Keep in mind that all the data are either collected from the maintenance shop floor, or they are collected from the aircraft, and we have both collected and real-time data. So here we are creating an investigation, and we will run some semantic analysis to be able to understand what happened to the sensor, what was wrong with it. So we run through the analytics of the fleet. We have the different operations that have been performed on that aircraft, like installation or removal of the sensor during the last maintenance operations. We can integrate this information into our report. And we can also have a look at a specific aircraft to better understand what happened, what was the in-flight data or the ground speed altitude, what was the temperature of the brakes at a given moment, so we can understand what happened on the aircraft. All of this data, they can come from different systems, but they are all stored in the 3DEXANS platform, so you have all the data from all the systems available in one place. That's really a plus for the analyst to understand what happened on the issues that have been reported. And we can also improve the maintenance prediction based on this report. For example, we are able to understand what happened in the past and what will potentially happen in the future to have a better maintenance prediction and plan the maintenance task ahead of time, replace the sensor before we have any issue on it. We can also go further in the investigation by analyzing and comparing the failure symptoms of an equipment happening during the flight. So in that case, as you have here, we can go through the troubleshooting, better understand the different symptoms on the selected flights, what are the associated items that failed, and we can better understand what will be the next failures. So to conclude, what I can say is that we would be very pleased to work with you if you could join us to transform and to improve the MRO operations. we are able with you to close the loop between the real world and the virtual world. We are able to consolidate the access to all the relevant data that you need. And based on this data, we are able to learn. So based on what you do, what operations you are performing, you are able to learn from them. Also, an important point that we wanted to talk about and to showcase to you today is that we can leverage collaboration between actors, between people, to work and to think differently, to rethink the way we are working, the processes we have, and finally improve our way to do maintenance on the aircrafts.